Today we're live coding the most brutal tech interview on the planet, designing Google search from scratch. 3 engineers who have bombed this before, 1 ex-Googler who knows where the bodies are buried, and 45 minutes to build the system that indexes the entire fucking internet. No textbook answers, no hand-waving, just raw engineering panic in real time. I'm Sam, and this goes sideways fast.
I failed Google search design twice. First time I spent 30 minutes building PageRank from scratch and completely forgot about crawling. Second time I designed this beautiful distributed system that could handle exactly 0 web pages because I ignored storage entirely. Both interviewers looked at me like I'd just shit on Larry Page's desk.
Made it to the final round but crashed on the crawling strategy. Turns out saying just crawl everything when there are 50 billion web pages is not a fucking strategy. Who knew? The interviewer asked how long it would take to crawl the entire internet and I just froze like a deer in headlights.
I actually got hired at Google, but only after failing search design 4 times. Each failure taught me something crucial about how they think about impossible problems. The key insight: they don't want you to solve search. They want to see how you break down the unsolvable.
Alex, you're our interviewer since you survived the gauntlet. Maya and Derek, you're our sacrificial lambs. No mercy, no hints, just pure Google-style psychological warfare.
All right, design Google search. 8 billion queries per day, 130 trillion web pages, sub 200 milliseconds response time globally. Your time starts now.
Jesus Christ, okay, requirements first. What's our target accuracy? Like how often should we return relevant results?
You tell me. What's an acceptable failure rate when people are searching for medical information?
Shit, that's dark. Medical queries need like 99.9% accuracy. But cat videos, maybe 95% is fine.
Good, you're thinking about query types. But how do you know a query is medical versus entertainment at index time?
We don't, that's a query time decision. We need to classify intent when the user searches, not when we build the index.
Exactly. Now scope this thing. How many web pages exist?
You said 130 trillion. But that can't all be unique content, right? Probably massive duplication, spam, auto-generated garbage.
Good instinct. Real number is probably 50 to 60 billion unique, useful pages. But how do you discover them?
Web crawling, start with seed URLs, follow links recursively, build a graph of the entire web.
Stop, you just said crawl the entire web. Do you have any idea how fucked that is at scale?
Oh fuck crawl budget, you can't just spam every website with requests. Most sites would collapse under that load.
Exactly. So how do you prioritize what to crawl?
PageRank, higher authority sites get crawled more frequently. Popular pages are more likely to have fresh, valuable content.
Chicken and egg problem. How do you calculate PageRank without crawling everything first?
Damn it, you need some initial crawl to bootstrap the link graph, then iteratively improve as you discover more links.
Better, but PageRank isn't the only signal. What else affects crawl priority?
Update frequency. Sites that change often need more frequent crawling. News sites versus static corporate pages.
Good. What about site health? Server response times, robots.txt compliance.
Right, if a site is slow or blocking crawlers, reduce its crawl rate. Don't want to DDoS anyone or waste resources on uncooperative sites.
Now the hard part, you've crawled a page. How do you extract searchable content?
Parse the HTML, extract text, identify title tags, meta descriptions, heading structure.
What about JavaScript? Half the modern web is client-side rendered.
Fuck, that's expensive. You need a full browser engine to execute JavaScript and render the final DOM. That's like 10x the compute cost per page.
Closer to 100x. So how do you decide which pages deserve JavaScript rendering?
Heuristics, check if the static HTML has meaningful content. If it's mostly empty divs and script tags, it probably needs rendering.
Not bad, but you're thinking small. How do you process 50 billion pages?
Distributed processing. Partition pages across thousands of machines, process in parallel.
How do you partition? By domain, by URL hash.
URL hash makes sense for load balancing, but then you lose locality. Pages from the same site might be on different machines, so you can't share robots.txt or site-level metadata.
Good catch. So how do you balance load distribution with data locality?
Hybrid approach, primary partition by domain for locality, secondary partition by URL hash within each domain for load balancing.
Workable. Now you've processed all these pages. How do you store them for search?
Inverted index. For each word, store a list of documents containing that word with position and relevance scores.
Size estimate for your inverted index.
Oh shit, 50 billion pages, average 1,000 words per page, that's 50 trillion word instances. Even with compression, that's petabytes of index data.
More like hundreds of petabytes. How do you query that efficiently?
Distribute the index, shard by term, so all documents for Python are on one machine, all documents for Java on another.
What happens when someone searches for Python Java?
Cross-shard query, fetch posting lists from multiple machines, compute intersection. That's going to be slow as hell for multi-term queries.
Exactly. Alternative sharding strategy.
Shard by document instead. Each shard contains a subset of documents but the full vocabulary. Then you can process multi-term queries locally on each shard.
Better, but now you need to query all shards for every search. How many shards?
Depends on shard size limits. If each shard can handle maybe 100 million documents, that's 500 shards minimum for 50 billion pages.
500 shards, 200 milliseconds query latency target. What's your parallelization strategy?
Query all shards in parallel, each returns top-end results, then merge and re-rank globally. But that assumes each shard can respond in under 200 milliseconds.
What if 10% of shards are slow? Do you wait for stragglers or return incomplete results?
Timeout and return incomplete. Better to show 90% of results fast than 100% of results slow. Users will just try another search if it takes too long.
Good instinct, but what about result quality? Maybe those slow shards contain the best results.
Hedge queries send the same query to backup shards with a slight delay. If primary shards are fast, cancel backups. If primary is slow, use backup results.
Expensive but effective. Now the million-dollar question, how do you rank results?
PageRank again, pages with more high-quality inbound links rank higher.
PageRank is 30 years old. What else matters for ranking?
Content relevance, freshness, user engagement signals, domain authority, page load speed.
How do you measure user engagement at scale?
Click-through rates, dwell time, bounce rate. But that requires tracking user behavior across the entire web. That's a privacy nightmare.
Exactly. How do you balance signal quality with user privacy?
Aggregate and anonymize. Track engagement patterns at the page level, not individual users. Use differential privacy to add noise while preserving signal.
Good, but what about real-time updates? New pages, updated content, breaking news.
You can't rebuild the entire index for every update. Need incremental indexing. New pages get added to a delta index, then periodically merged with the main index.
How do you query across both main and delta indexes without double counting?
Version stamps. Each document has a timestamp. When merging results, take the latest version and discard duplicates.
What about deleted pages? How do you remove them from search results?
Tombstone records mark deleted documents with special flags instead of physically removing them. Filter them out at query time.
Decent approach. Final question, how do you handle spam and low-quality content?
Content quality signals. Keyword stuffing detection, duplicate content filtering, link farm identification.
Spammers adapt faster than your rules. How do you stay ahead?
Machine learning. Train models on known spam examples, let them generalize to new patterns. But then it becomes an arms race between spammers and your models.
Exactly, and that arms race never ends. Time's up. Maya, you got distracted by PageRank again and missed critical infrastructure questions. Derek, better systems thinking, but you need to be more decisive about trade-offs.
Holy shit, that was brutal. What just happened that's different from typical system design prep?
Real Google search interviews expose how impossibly complex this problem is. They don't want textbook solutions. They want to see how you think when facing the fundamentally unsolvable. Search at Google's scale breaks every assumption you have about distributed systems.
I kept falling into the PageRank trap. It's such an elegant algorithm, but it's just one tiny piece of modern search. I should have focused on the infrastructure horror show instead.
Every answer opened 3 new problems. Crawling leads to storage, storage leads to indexing, indexing leads to querying, querying leads to ranking. And suddenly you're building the most complex system ever created.
Let's break down the moments where candidates typically lose it completely. This episode was brought to you by Unstruct AI, where we explore the human cost of building systems that process the entire fucking internet. Progress without humanity isn't progress at all. We're back. Alex, you've seen hundreds of these search design interviews. What separates the engineers who get hired from those who crash and burn?
It's not about knowing Google's exact architecture. It's about understanding that search is fundamentally an impossible problem that you solve through infinite layers of approximation and optimization. Most candidates try to solve it perfectly. Great candidates figure out how to solve it good enough at impossible scale.
That's what killed me both times. I was so focused on algorithmic elegance that I forgot about the physical reality of indexing 50 billion web pages. You can't just hand-wave storage and say distributed systems will handle it.
The scale numbers are what fuck with your head. 8 billion queries per day sounds manageable until you realize that's 100,000 queries per second during peak hours, each touching hundreds of petabytes of index data.
Exactly. Google engineers think in terms of physics, not just computer science. You can't search the internet faster than light can travel, you can't store infinite data, you can't compute perfect relevance in zero time. Everything is a trade-off.
Let's replay that moment where Maya almost lost it completely, the JavaScript rendering problem.
God, that was a nightmare. I said parse the HTML like it's 1999, completely ignoring that modern web development is basically JavaScript soup. When Alex mentioned 100x compute cost for rendering, I felt my soul leave my body.
That's the trap. Candidates think about the web as static HTML because that's what they learned in school. But reality is React apps, Angular frameworks, dynamic content generation. The modern web is hostile to crawling.
And you can't just render everything because the compute cost would bankrupt even Google. So you need these impossible heuristics to guess which pages are worth the expensive processing.
What about the indexing discussion? That seemed to break both candidates' brains.
The sharding problem is genuinely unsolvable. Shard by term and multi-word queries become nightmares. Shard by document, and you need to query 500 plus machines for every search. Both approaches are terrible in different ways.
That's exactly the insight Google wants to see. Not, here's the perfect solution, but here are the impossible trade-offs and how we choose the least terrible option. Real engineering is about managing complexity, not eliminating it.
The ranking discussion broke my brain too. I kept thinking about PageRank because it's mathematically beautiful, but modern search uses hundreds of signals. User engagement, content freshness, domain authority, page speed. How do you even weight all those factors?
Machine learning. But that opens another can of worms: training data bias, adversarial attacks, model freshness. Every solution creates new problems. Google's advantage isn't having perfect algorithms, it's having better infrastructure for managing imperfect solutions at scale.
What about the human elements that typical system design prep completely ignores?
The spam and content quality stuff was eye-opening. It's not just a technical problem, it's warfare against people actively trying to game your system. They adapt faster than your algorithms can update.
Search is fundamentally about understanding human intent and information quality. The technical infrastructure exists to serve that goal. Candidates who focus only on distributed systems miss the point entirely.
And the privacy trade-offs are brutal. You want user engagement signals to improve relevance, but tracking user behavior is creepy and potentially illegal. Every feature that makes search better makes privacy worse.
Let's get practical. For someone preparing for Google search design interviews, what should they focus on?
Understand the physical constraints. Crawling 50 billion pages takes months. Storing hundreds of petabytes costs millions. Querying distributed indexes has latency limits. Start with physics, then figure out the algorithm.
Don't fall in love with PageRank. It's historically important, but it's a tiny piece of modern search. Focus on the infrastructure nightmare: crawling, storage, indexing, querying. The algorithms are almost secondary.
Think about the adversarial environment. Spammers, scrapers, SEO farms, they're all trying to manipulate your system. Every algorithm you design will be gamed. Plan for that from the beginning.
Most importantly, embrace the impossibility. Search can't be solved, only approximated. The best engineers I work with are comfortable with permanent imperfection. They optimize for good enough at impossible scale, not perfect in theory.
Any red flags that immediately disqualify candidates?
Saying we'll use machine learning without understanding the data pipeline. Or we'll just shard it without thinking through query patterns. Hand-waving at scale kills you instantly. Also, anyone who thinks they can build better search than Google, usually has no idea what they're talking about.
Or obsessing over PageRank like I did. It's historically important, but if that's all you know about search ranking, you're fucked. Modern search uses hundreds of signals, and most of them have nothing to do with link analysis.
Not asking about constraints and trade-offs. Real engineering is all about choosing which things to sacrifice. If you're not making hard choices, you're not solving real problems.
What's the biggest misconception people have about these search design interviews?
That there's a correct answer. There isn't. We want to see how you think about impossible problems, how you break down complexity, how you prioritize trade-offs. The solution you propose is almost irrelevant compared to your reasoning process.
I kept trying to impress with clever algorithms when I should have focused on boring infrastructure. Managing petabytes of data reliably is way more impressive than implementing PageRank from scratch.
And they're not testing your knowledge of specific Google technologies. They want to know if you can reason about systems at a scale that breaks normal assumptions. That's a mindset, not memorized facts.
Final question, what would you tell your past selves before that first Google search interview?
Stop trying to solve search and start trying to understand it. The goal isn't to design the perfect system, it's to show you can think clearly about the most complex system ever built. Humility beats hubris every time.
Focus on the constraints, not the algorithms. Storage costs, network latency, computational limits, these shape everything. Start with physics and work backwards to the computer science.
Be honest about what you don't know. Saying, "I'm not sure how to handle that edge case, but here's how I'd investigate," is infinitely better than bullshitting through an answer. We hire people who can learn, not people who know everything.
This has been absolutely fucking brutal. We've seen how real Google search interviews differ from textbook prep. It's about engineering judgment under impossible constraints, not memorized algorithms.
Thanks for the reality check, Alex. This felt more like actual engineering than any practice session I've done. Now I understand why 99% of engineers fail this thing.
Agreed, the human psychology aspects, the adversarial environment, the physical constraints, that's the stuff you only learn from actually trying to build systems at Google's scale.
Keep practicing, but focus on reasoning over memorization. The best engineers I work with are curious problem solvers who understand their limitations. Search is humbling. Let it humble you.
Until next time, remember that system design is about humans, not just systems. We build technology to serve people, even when that technology processes the entire fucking internet.
And if you're interviewing at Google, think like a user first, engineer second. Search exists to help humans find information. Everything else is just infrastructure to serve that goal.
Thanks, everyone. Time to go practice calculating storage requirements for 50 billion web pages, and maybe learn what the modern web actually looks like.
And I need to understand distributed query processing. Apparently, just shard it isn't a real architecture strategy. Who knew?
This has been Unstruct AI, where we strip away the bullshit and show you how technology really works messy, impossible, and surprisingly human.